You've described our everyday experience, Sophia. We live our lives surrounded by familiar sights and sounds, moving through spaces that feel natural and intuitive. Whether we're at home, walking in the park, or navigating a bustling city, everything about our world seems to fit perfectly into three dimensions. We are creatures of three spatial dimensions. Up and down, left and right, forward and backward. These are the directions that shape our reality. Our bodies, our homes, even the cities we build, all exist within this three-dimensional framework. Every object, every place can be pinpointed using just three coordinates, like a cosmic address. With just length, width, and height, we can describe the position of anything, from a tiny grain of sand to a soaring skyscraper. It's a system so reliable that it guides everything from ancient explorers to modern GPS satellites. For centuries, this was our complete picture of reality, the world of Newton, a predictable, clockwork universe. The laws of motion and gravity seem to explain everything, from the fall of an apple to the dance of the planets. The universe appeared orderly, almost mechanical, and three dimensions were all we needed to make sense of it. S1, as Prof. Sophia Mendes. Exactly! It's what we see, what we feel. Our senses are built for this world, and our intuition rarely leads us astray within it. When I throw a ball, it travels through this three-dimensional space. Its path can be traced, predicted, and understood using the rules we've always known. The ball arcs through the air, obeying gravity and momentum, never straying into some mysterious extra direction. The idea of a fourth spatial dimension just sounds like science fiction. It's the stuff of wild stories and imaginative movies, not something we expect to encounter in our daily lives. We're so used to our three dimensions that anything more seems impossible, almost magical. Where would it even be? If there's another direction, it's not one we can point to or walk along. It's invisible to us, hidden from our senses and our experience. If there were another direction, wouldn't we have noticed it by now? After all, we've explored our world in every way we can imagine. We've built skyscrapers, tunneled underground, and even sent probes into space. Yet we never stumble into a fourth dimension. That's the crucial question. Our senses are tuned for survival in three dimensions, but they don't define all of reality. Just because we can't see or touch something doesn't mean it isn't there. Think about what our senses miss. Ultraviolet light, ultrasonic sound. Our perception is limited. Bees see colors we can't imagine. Bats navigate with echoes we can't hear. The universe is full of phenomena that exist beyond our natural reach, waiting to be discovered with the right tools and ideas. Physics, especially in the last century, began to uncover strange new rules. The more we probe the universe, the more we realized that our familiar three dimensions might not be the whole story. Equations hinted at hidden layers, at possibilities that defied our everyday experience. It found hints in its equations that our three-dimensional world might just be the visible part of a much grander theater. The cosmos could be far richer and more mysterious than we ever imagined, with hidden dimensions woven into its very fabric. S1, as Prof. Sophia Mendes. So there could be more to reality than we can see or touch. Maybe our senses are just scratching the surface and there's a deeper reality waiting to be explored. Exactly. The universe may be hiding more than meets the eye. What we perceive is only a fraction of what's truly out there. The unknown beckons, challenging us to look beyond the obvious. S1, as Prof. Sophia Mendes. That's both unsettling and exciting. It means there's so much more to learn, and so many mysteries left to solve, and it's only the beginning. As we push the boundaries of knowledge, we may discover that reality is far stranger and more wonderful than we ever dreamed. The motivation was powerful, unifying two of our most successful theories, Einstein's general relativity and quantum mechanics. These theories work perfectly in their own domains, but when combined, the math breaks down. S1, as Prof. Sophia Mendes. So, we had two rulebooks that contradicted each other. How does adding more dimensions help? Enter string theory. It proposes that the universe's fundamental building blocks are tiny vibrating strings. Different vibrations create different particles. An electron is one vibration, a photon another. But for string theory's math to work, it requires more than three spatial dimensions. S1, as Prof. Sophia Mendes. So, extra dimensions aren't just a wild idea, they're a mathematical necessity? Exactly. Without them, the theory falls apart. S1, as Prof. Sophia Mendes? That's a bold claim. The most popular versions predict 11 dimensions, 10 of space, 1 of time. We experience 3 of space and 1 of time, so where are the other 7? S1, as Prof. Sophia Mendes. How do you hide a dimension? It's not like you can put it in a box. The leading idea is that these extra dimensions are compactified, curled up at an incredibly small scale, far smaller than an atom. At every point in our space, there's a tiny, complex, seven-dimensional shape, too small for us to notice. S1, as Professor Sofia Mendes. So they're everywhere, but hidden in plain sight. Exactly. Picture a garden hose. From far away, it looks like a one-dimensional line, but an ant walking on it can move forward and also around its circumference. S1, as Professor Sofia Mendes. So, from a distance, we see only the long dimension, but up close, there's a hidden circular direction. That's the idea. We see three stretched out dimensions, but at every point, there are tiny looped directions. If you could shrink down enough, you'd find other ways to move, directions invisible to us. S1, as Prof. Sofia Mendes. So the universe is like a hose, and we're just too big to notice the loops. Exactly. The extra dimensions are looped so tightly, we never notice them. These extra dimensions aren't just simple circles, right? When we talk about the fabric of space-time, it's easy to imagine a flat sheet or a simple grid. But the reality, according to string theory, is far more intricate and mind-bending. These hidden dimensions are not just tucked away, they're curled up in fantastically complex ways, invisible to our eyes but essential to the universe's structure. There are 7 of them. What do they look like? Imagine trying to picture a shape so complicated it can only exist in mathematics. These aren't just extra lines or circles, they're entire worlds of geometry, each with its own unique twists and folds. S1, as Professor Sofia Mendes. They form intricate shapes called Calabi-Yau manifolds, multidimensional, twisted, folded, and crumpled up, smaller than anything we can measure. These manifolds are so tiny that even our most powerful microscopes can't detect them, yet they're everywhere, woven into the very fabric of reality. Each possible shape could create a universe with different physical laws. The way these dimensions are folded determines everything from the strength of gravity to the types of particles that exist. It's as if every possible universe is hidden in the folds of these tiny shapes. So the geometry of these hidden dimensions determines the physics of our universe. It's almost like the universe is built on a secret blueprint, one that shapes the rules we live by. S1, as Professor Sofia Mendes. Exactly. The tiniest details of these shapes ripple out to affect everything we see and experience. The way strings vibrate depends on the shape of the Calabi-Yau manifold, just as a guitar string sound depends on its length and tension. If you change the shape, you change the music, and in the universe, that means changing the very particles and forces that make up reality. The universe's fundamental constants might be outcomes of this hidden geometry. Numbers like the speed of light or the strength of electromagnetism could be set by the way these dimensions are curled up, like dials on a cosmic control panel. So, the universe's control panel is hidden in this multidimensional origami. Each fold, each twist, is a setting that shapes the cosmos we know. S1, as Professor Sofia Mendes. That's the beauty of it. The universe is more mysterious and elegant than we ever imagined, with its deepest secrets hidden in the tiniest, most intricate corners of reality. Are there other ways to hide extra dimensions? What if they're not tiny, but huge, and we're just stuck in our corner? S1, as Dr. Reed. That's Brane theory. The extra dimensions could be vast, but we, and all matter and forces except gravity, are confined to a three-dimensional brain in a higher dimensional bulk. Imagine our universe as a slice of bread in a larger loaf. We can move within our slice, but we're stuck to it. So everything we know is just a thin membrane in a higher dimensional reality. S1, as Dr. Reed. Exactly. All particles are stuck to our brain, which is why we don't see the extra dimensions. There could be other brains, other universes floating nearby, invisible to us. That's staggering.
It opens up wild possibilities.
You said all forces except gravity are stuck to the brain. S1, as Dr. Reed. Gravity is much weaker than the other forces. Brane theory suggests it's not inherently weak, its influence is diluted because it leaks into the extra dimensions. So we only feel a fraction of gravity's true strength because most of it spreads into other dimensions. S1, as Dr. Reed. Exactly. Gravity is produced by closed loops of string, free to roam the higher dimensional bulk. If gravity leaks into extra dimensions, we might detect tiny deviations from Newton's law at small distances. Experiments are searching for signs of energy disappearing from our brain, evidence of gravitons escaping into the bulk, so gravity could be our clue to hidden dimensions.
That's the hope.
If these dimensions are real, could we ever see them? Or are we forever stuck in 3 dimensions? S1, as Dr. Reed. Visiting tiny curled-up dimensions is likely impossible. They're smaller than atoms. But we might interact with them by making particles vibrate in those directions, detecting them indirectly. And what about the Brane model? Could we ever reach another Brane? S1, as Dr. Reed. Travel seems impossible since we're made of matter stuck to our brain, but some theories suggest black holes could briefly connect brains. For now, our best hope is indirect evidence, missing energy in particle collisions or subtle gravitational effects. The ultimate journey remains a dream.
But science keeps pushing the boundaries.
Imagine standing at the edge of the ocean, gazing up at the stars, and realizing that the universe itself might be just a tiny island in a much vaster cosmic sea. The idea of extra dimensions would completely reshape our understanding of where we fit in the grand scheme of things. Our universe, as immense and mysterious as it seems, could be just a sliver, a single thread woven into a much larger multi-dimensional tapestry of reality. S1, as Dr. Reed. It's the ultimate Copernican revolution. Just as Copernicus showed us that Earth isn't the center of everything, the discovery of extra dimensions would reveal that our universe isn't the whole story. Over centuries we've learned we're not the center of the solar system or the galaxy, or even the universe itself. Each discovery has humbled us, showing that reality is far bigger and stranger than we once believed. The possibility of extra dimensions would humble us even further, reminding us that our universe could be just one small feature in a vast, multi-dimensional reality that stretches far beyond our imagination. Just as the ocean hides its depths beneath the surface, so too might the cosmos conceal hidden dimensions, waiting to be discovered by those willing to look deeper. It changes the question from, what is in the universe, to something even more profound. Now we must ask, what is the universe in? What greater reality might surround and contain everything we know? S1, as Dr. Reed. The search for these dimensions isn't just about math or abstract theory, it's about finding the true scope of our home and understanding our place within it. It's about expanding our sense of belonging, realizing that Earth, and even our universe, might be part of something far grander than we ever imagined. Science is about asking questions, pushing boundaries, and daring to imagine that reality is stranger and more wonderful than it appears on the surface. Every new discovery opens a door to the unknown, inviting us to explore, to wonder, and to dream. The universe has surprised us before, again and again, with its beauty and its mysteries. The possibility of hidden dimensions is perhaps the most profound surprise of all. The cosmos is calling us to look beyond what we know, and its secrets are waiting, just beyond the horizon of our understanding, ready to be discovered by those who dare to seek.